Alright, lesson 12.3, finding the sum of angle measures. That's kind of a general title here, but as we go into these examples, you'll see what it's talking about. First off, let's define an interior angle, and this is a really terrible definition. An interior angle of a polygon is an angle that's inside the polygon. I'll draw an example out here in just a second. So inside a polygon, we talked about these angles when we were looking at the angles of a triangle, which is a specific type of polygon. We talked about particular quadrilaterals. Now we're just going to be a little bit more general and talk about the measures of these angles in any particular type of convex polygon. Now, the measures of the interior angles of a convex polygon, that means if you add up all the interior angles of a convex polygon, you can use this formula. Now, we know with a triangle that the measures of the three interior angles is 180. Three sides, a triangle is an n-gon, it's a three-gon, it's a triangle. If we substitute 3 in here, 3 minus 2 is 1, 1 times 180 is 180 degrees. We also know that with a quadrilateral, the sum of the measures is 360. A quadrilateral is like a four-gon, I guess that was a foregone conclusion. 4 sides, if I plug 4 in, 4 minus 2 is 2, 2 times 180 is 360 degrees. But this guy works for any kind of convex polygon. Let's try a couple of examples here. Find the sum of the measures of the interior angles of a convex polygon with a given number of sides. 9 sides, a nonagon. So what I'm going to do is I'm going to plug 9 in for n. I'm going to have 9 minus 2 times 180 degrees. Well, 9 minus 2, of course, is 7. 7 times 180 degrees. Let's see if I can do my arithmetic here. 6 carry a 5 looks like 1260 degrees for all 9 interior angles. Now let's try one here with 6 sides. That's a hexagon. If I plug 6 in for n, I get 6 minus 2 times 180, which is going to be 4 times 180 degrees, which is going to be 720 degrees. So I'm able to find the sum of all of those angles in a 9-sided polygon, a 6-sided polygon, by using this formula right here. Good one to remember, good one to memorize. Now remember, in this next example, what it means when you have a regular polygon. A regular polygon means all the sides are the same length and all the interior angles are of the same measure. We're asked to find the measure of an interior angle of a regular octagon. I start off by using this formula to find the sum of all of the angles. So I'm going to plug in 8 in for n, 8 sides, 8 minus 2 times 180. So 8 minus 2 is 6 times 180, which is 1080 degrees. That's not my answer. That's all of them. To find the measure of just one of them, since it's a regular octagon, they're all the same size, all 8 angles. So I'm just going to take the total and I'm going to divide by 8. Now let's see if I can do that. 8 goes into 10 once, 28, that would go in 3 times, 40, that would go in 5 times. So one angle would be 135 degrees. The next time you're at a light or at a stop sign, let's say, look at that stop sign, it's a regular octagon. Look at each of the interior angles and you can tell right off the bat they're 135 degrees. Alright, let's define what we call an exterior angle. We talked about interior angles, let's talk about exterior angles. The exterior angle is when you extend the side of a polygon. It's the angle that's adjacent to the interior angle. Now I have a couple polygons, I have a triangle and a pentagon there, and I've numbered the interior angles 1, 2, 3, 1, 2, 3, 4, 5. What I'm going to do is I'm going to start off with the triangle and I'm going to construct an exterior angle to this shape, to this triangle, at vertex or at angle 1. So I have to extend either this side here or this side here. I'll extend this side here at the bottom like this. This angle that's formed right here, which I'm going to call angle 4, is an exterior angle. It is exterior because it's from the extension of the side and it's adjacent to angle 1. Now if you're wondering, well, what would have happened then if you'd extended this side? Would you get an exterior angle? Yes, I would. If I extend this side like this, then my exterior angle is right here. I'll call that angle 5. See, every vertex, every interior angle has 2 exterior angles, 1 at each vertex, or 2 at each vertex. So what's going to happen here is I'm going to look at typically 1 at a time, because you can see that these 2 angles are indeed vertical angles and they are congruent. Now if you're wondering about angle over here, this angle right here, that is not an exterior angle because it's not adjacent to the interior angle, angle 1. See, again, every interior angle, if I extend the side, you see the exterior angle that's formed here? I could call this angle 6. It's adjacent to angle 3, or I could extend the side this way, and I would have an angle here. This is called angle 7. That would be an exterior angle at this vertex. And of course up here, the same kind of a deal runs. I have two exterior angles that are formed, and I could call those, let's see, I got 7, I could call this one 8 and call this one 9. You can see it is adjacent to the angle, angle 2. It's adjacent to the angle, alright? Now I can do the same thing here at all 5 of these, but I'm just going to use angle 4. I'm going to extend the side and you can see the exterior angle that's formed. Now one nice thing about exterior angles is that the sum of every exterior angle, that's 1 per vertex, adds up to 360 no matter what kind of a polygon, convex polygon we're dealing with. Triangle, quadrilateral, pentagon, hexagon, it doesn't matter. It doesn't matter how many sides. If we add up the exterior angles, again, 1 per vertex, because I know there's 2 at each vertex, 1 per vertex, it always adds up to 360. That's pretty convenient. Now I'm going to use that idea to work the following problem. In this next problem here, I'm actually not for this particular problem, I'm going to get to it, but for the problem down there, I'm sorry. In this particular problem here, I'm going to find the measures of angles 1 and 2. To do that, first off, angle 1, this angle right here, these are the 3 interior angles of a triangle. They have to add up to 180. So if I add up the 2 that I know, they add up to 155 degrees. If I subtract from 180, the measure of angle 1 is going to be equal to 180 minus 155, which is 25 degrees. So now, since I know the measure of angle 1, and since angle 1 and angle 2, these two angles form a linear pair, they're supplementary angles, angle 2 must be 180 minus the measure of angle 1. Well, 180 minus 25, the measure of angle 2 is 155. Now, look at this and look at this. The same two amounts. I'm telling you that this exterior angle right here, this exterior angle, its measure is equal to the sum of these two measures here. Now these are two interior angles, but it's not the adjacent angle. This interior angle is to angle 2 here. This exterior angle is adjacent to angle 1. It's not adjacent to these two. These two angles are called remote interiors. I always remembered because they're further away from the exterior angle, so you need your remote control because you're too far away. This interior angle, you're adjacent to it, so you could just reach over and change the channel manually. But here you would need the remote because they're further away. The sum of the measures of the two interior remotes is equal to the measure of that exterior angle. Now, this particular example, or actually let's go over here. This particular example, find the measure of the exterior angles of a regular 12 gun. Now this is where I'm going to use this guy right here. Okay, if it's regular, first off, all the measures add up to 360. All the measures of the exterior angles add up to 360. If it's a regular polygon, in this case a 12 gon, which is like a dual decagon or something like that, what happens is each of the interior angles is congruent. Remember, regular means all the sides are congruent to one another and all the interior angles are congruent to one another. So if I have a regular 12 gon, what's going to happen is each of the interior angles is of the same measure, which means each of the exterior angles will be of the same measure. So all I have to do is take 360, which is the sum, and divide by 12. Because I'm talking about 12 exterior angles, 1 per vertex, and that equals 30 degrees. And that would be an exterior angle. Now, let's say I tell you what, let's go back to this problem real quick. If we wanted to find the interior angle, we would do 12 minus 2 times 180, which is 10 times 180, which is 1,800. If I now divide this by 12, because there's 12 interior angles, each interior angle would add up to, or would measure 150 degrees. So if each interior angle, like let's say it was this angle right here was 150 degrees, then the exterior angle would have to be 30 degrees because they form a linear pair, and that matches up with what we have here. Now let's go to this last example. Find the unknown angle measure in the diagram. That's this guy right here. I'm going to find this measure. It looks like it's an acute angle here. Well, I know that all 5 exterior angles, one per vertex there, will add up to 360 degrees, right? So I have this is 90, so that means this angle, this exterior angle is 90. This is 90 here, so this exterior angle is 90. They form linear pairs. I have this one at 52, this one at 82, and I'm trying to find x. I don't have a lot of space here, but well, maybe I can squeeze it in. I'm going to write x plus 82 plus 52 plus 90 plus 90. X, 82, 52, 90, and 90 better add up to 360 degrees. Let's see. 82 and 52 is 134. 134 and 180 is 314. So I have x plus 314 equals 360. Subtract 314 from both sides. I don't even know if you can see that. I'm going to get x is equal to, looks like 46 degrees, and that's the angle in question. So look this over and practice, practice, practice.